Okay, so hi there, folks. So we're going to continue our batch of videos in college algebra. Now we're still here in our chapter in exponents and radicals, and we're going to talk about today about zero and the negative integral exponents. So we need to first observe this certain phenomenon where using the second law of exponents, what we have is, imagine we have a term which is raised to a number. Let's make it a specific example, a squared. Let's divide it with the same number, which is also a squared. So what will happen here? So by the second law of exponents, what we'll do is the power in the numerator minus the power of the denominator. Thus, what we have is a squared minus 2. Or rather, we can say it as a raised to 2 minus 2. Okay, that I think that's the proper way of saying that. Sorry, a raised to 2 minus 2. Okay, so 2 minus 2, we know that as a 0. So what we have here as our final answer is the a raised to 0. So we just need to observe that a raised the answer of any division of terms wherein we have the same exponent is going to give us 0. Similarly, what we can also see that if we are given specific integer examples. So what we have is 3 raised to 5, whatever this number is, okay, divided by the same number, 3 raised to 5, as you can see. So I think there's a hidden step here, which is going to be similarly here. It's going to be 3 raised to 5 minus 5. So which is, of course, 5 minus 5 is 0. So this is our answer for this specific example. We fix that. Okay. So also we have learned that any number divided by itself is equal to 1. So we know that, any number 3 divided by 3, how many 3's are there in 3's? Of course, there's 1. 15 divided by 15, how many 15's are there in 15's? Of course, there's 1. So generally, we can say that any number x divided by any number by the same number x is going to give us 1 for all x's. Okay, so that's it. Any number divided by itself is equal to 1. Okay, so therefore, thus we can say that a squared over a squared is going to give us 1. Likewise, or similarly, 3 raised to 5 over 3 raised to 5 is going to give us also 1. Okay, so 3 raised to 5 divided by 3 raised to 5. So I will be using this example, this a raised to 2, or a squared divided by a squared here. So since we have established by the second law of exponents that a squared over a squared is going to give us a raised to 0, and a squared over a squared is going to give us the same number, which is equal to 1. So by transitivity, or by the transitive property of equality, think you I hope you can remember that that states that if A is equal to B and B is equal to C, therefore we can say that A here is equal to C. So that's transitivity. So we're like, you may think of it like we're practically bypassing B, because we say that A, the first term, is equal to B, and then this B term is equal to the last term C. So therefore we can state that A is equal to B is equal to C. So we're like bypassing the B part. So A is equal to B. A is equal to C, rather. So that's transitivity. That's the transitive property. So since we have established that a squared over a squared is equal to a sub 0, or rather a raised to 0. Okay, sorry, a raised to 0, and a squared over a squared is equal to 1. So therefore, we can say that a raised to 0 is equal to 1. So imagine this is our a, or rather, let's make use of capital letters. This is our a, this is our b, this is our a again, this is our b, this is our a, this is our c. So meaning if a is equal to b and a is equal to c, therefore b is equal to c. Okay, so that's still transitivity. Similarly, in the case of our second example, 3 raised to 5 over 3 raised to 5 is going to give us 3 raised to 0 is equal to 1. So therefore, 3 raised to 0 is equal to 1. As you can see in these two examples, the common thing which is happening here is that both of them have an exponent which is equal to 0. Okay? both of them have an exponent which is equal to 0. So therefore, by this practical examples here, we can state a general form, okay, of this property. So therefore, we can say this property over here. Okay, so we call this the zero exponent property. So what does it say? So the zero exponent tells us that any quantity, anything at all, except zero, okay, so please take note of this, except zero, okay, with a zero exponent has a numerical value of 1. Okay, so any quantity except zero with a zero exponent, take note, with a zero exponent, so if it has a zero exponent, um, has a numerical value of 1, meaning in short, it's equal to 1. So in symbols, we have a raised to 0 is equal to 1 for all a which is not equal to 0. Okay, so I forgot to put that. Okay, so what does it mean? So meaning any a here, imagine any a, anything at all, okay? May it be a variable, may it be a quantity, may it be an integer, anything at all raised to 0 is going to give us what? Anything except 0. Except 0. So what I mean is the exception is that 0 raised to 0 is not equal to 1. Okay, so what is 0 raised to 0 then? So uh it's not the scope of this lesson, but just I'll just let you know, in calculus we call this the interdeterminate form or the indeterminate form. Okay, so it's the indeterminate form, so it's not equal to 1. Okay, so anything at all except the 0, imagine this anything to be a, so a raised to 0 is gonna be this time equal to 1. Okay, or that's messed up, so just look at this thing here. A raised to 0 is equal to 1. So some examples, if you will want to have some clarifications, if this is not enough for you. So we have here some examples. So 5 raised to 0 is equal to 1. Let's check. Number 2, um, maybe you'll get confused. Okay, so number 2, negative 2, quantity. Okay, take note, the quantity, we have a parenthesis. Inside the parenthesis, we have minus 2. So minus 2, the whole of it, raised to 0 is going to give us 1. But take note, recall our first part in the exponents wherein I told you a misconception about, or rather a reminder about negative signs when we are raising it to 0, to any number. So we have here minus 7 raised to 0. So take note, um, the 7 here is not enclosed in a parenthesis, so meaning we're not it's not a single grouping. So in short, the one which is raised is not the negative 7 but only the 7. So 7 raised to 0 is 1, and we have a negative sign here outside, take note. So meaning we need to install also the negative sign in our power. So negative 7 without the parenthesis symbol telling us to raise the whole minus 7. But instead, we're just raising the 7, okay, to 0. It's going to give us 1, and then apply the minus sign. Or in short, if you want positive 1 times negative 1, it's going to give us minus 1. So yeah, that's it for this video. I hope you have learned something about zero exponents. And yeah, don't forget to hit like and kindly subscribe. So thank you very much.